Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Carnival by Math Pesto, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. Digits in a cage cannot repeat and must sum to the given total. So there are no repeats in these killer cages here, and they must sum to the given total. So, for example, here you could have something like, say, 2, 3, and 6. And this would be valid because these digits add up to 11, which is the number in the top left corner of the cage. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. For 8 cages, we are guaranteed that in those cages, there must be a 1. And the reason why we know that is because what 3 numbers, unique numbers, can ever add up to 8? It's only 1, 2, 5, and 1, 3, 4. So you're guaranteed a 1 in one of these and 1 in one of these, which means to add up to 11, that means there's no more 1s available in rows 3 and 4. Same with rows 6 and 7. These have to be 1s also. That means in row 3 and 4, there's no more 1s, which means this cannot contain 1. So what digits can add up to 11 here? It has to be, I think, 2, 3, and 6, right? No, 2, 4, and 5 could work. So we're guaranteed a 2 here. So these digits have to be 1 through 5 here. So we have 1 through 5 here. And this is 1 through 5 here. Well, if this is 2, 4, 5, the problem is in row 4, we would have 6 cells, which requires 5 digits in them specifically. So therefore, there's no possibility this could be 2, 4, 5. It has to be 6 here. So this is 6 with 2 or 3, and this is 2 or 3 there. Now this must be 1, 3. We have the same. So this is 6, which forces this to be 7, 8, 9 here. 7, 8, 9 remaining in the row. We have to have one of these be a 5. We have to have one of these be a 4. So one of these is 5 and one of these is 4, which means one of them's 1, 2, 5, and the other one's 1, 3, 4. So we're guaranteed a 2 in here. That means we're guaranteed a 2 here. So 5 and 4 are the ones here, which means this cannot be 4, 5. This cannot be 4, 5. We have a 1, 2, 3 triplet now in row 3. This requires a 9 to add up to 22. Same with that. But that's not too helpful. This is 1 through 5 here. This is also 1 through 5 here. What else do we have? So this is guaranteed a 2 or a 3 here. This has to be 5 through 9. And 5 through 9 here. Okay. Oh, so this can't be 1 either. So this has to have a 2. And we don't know if it's because of these pairs here. 1 cannot be remaining in... Because of these having to have a 1 here in columns 1 and 2, the rest of column 1 and 2 cannot be 1. So 1 cannot be here. 1 can't be here because of the 1, 2, 3 triplet in the row. So where is the 1 then in box 1? Can't be here because of these having to be 1. We have all the 1s accounted for in rows 1 and 2, or columns 1 and 2. And this can't be 1 because of the 1, 2, 3 triplet in the row. So this has to be 1 here. So this is 1, which eliminates 1 from being here. These can no longer be 1. 1 has to be one of these two. This can't be 1. Where is the 1 in this cage? It has to be here. So this is 1, which eliminates 1 being here. So where's the 1 in this cage? It has to be there. So that's 1 there. This is a 1 here. Where's the 1 in row 5? Can't be here because of 1's in the columns. Can't be here. Can't be here because of 1 in the row. Can't be here because 1 has to be one of those. So this must be 1 there. Okay. This then obviously could be 2. So these, okay, so we're going to mark these 2, 5 pairs instead of the blue for everything because we have the 1s now already sort of taken care of. So then this is going to be the blue pair of 2 and 5 adding up to 7. This is going to be the, we'll make it yellow pair adding up to 2, 5. And this cannot be the same as this, obviously. Because if this is 2, 5, then this can't be 2, 5 as a pair because that's not possible there, which means it would be 3, 4. If this is 3, 4, that forces this to be 2, 5. So this yellow pair means this can't be yellow. It's blue. This can't be blue, so the yellow has to be here. And we don't know about this. Oh, same problem here. This can't be 2, 4, 5 because if this is 2, 4, 5, okay, so this is guaranteed to be 6 here, guaranteed. And if this is 2, 4, 5, then we have 6 cells in row 7 requiring 5 digits, which is not allowed. So this has to be 6 with 2 or 3, and this is 2 or 3 here. We have a 2, 3, 2, 3 pair. Actually, this must be 2 or 3, so this can't be 2 or 3 here. So this is 1, 4, 5. We then have a 2, 3, 2, 3 pair in column 5, which eliminates 2 and 3 in the rest of the column. This can't be 2 or 3, it's 6, which makes this not 6. So this is 2 or 3, and this is 2 or 3 here. Which means this 2 or 3 cannot... We have a guaranteed 2 or 3 here. This is 2 or 3, so this cannot be 2 or 3. This is not 2 or 3, it's 2, 4, 5, so this is 2 or 3. This must be the yellow 2, 3, and this must be the green 2, 3 here. Okay, so where is the yellow 2, 3 in box 5? Can't be here because of the yellow 2, 3s in the column. Can't be here because of yellow 2, 3 in the row. So it has to be here. So this is yellow 2, 3. This must be blue 2, 3, which means this can't be blue 2, 3. It's blue 2, 4, 5, so that's blue 2, 3 there. Yellow 2, 3 is one of these two. We're not sure which. Where is 1 in box 2? Can't be here, so it must be one of these cells, which is in column 4 or 5. Where is the 1 in this cage? It must be also be in column 4 and 5. That eliminates 1s in the rest of columns 4 and 5. Well, where's the 1 in box 8? Cannot be in columns 4 or 5. Can't be here because of 1 in the row. Can't be here because it must add up with 2 other digits to add up to 20. And 1 only adds up with 8 and 9 to add up to 18. So 1 has to be here. Well, where's 1 in box 9? Can't be here or here because of 1's in the row. Can't be here because 1, 8, and 9 only add up to 18 at most. So 1 has to be here, which means where's the 1 in column 7? Can't be here because of ones in the boxes. Can't be here because of one in the row. Can't be here because of what the cage adds up to, so it must be there. Which means where is the one in row 2? Can't be here or here because of ones in the box. Can't be here because of the cage, so it has to be here. So this is 1 which eliminates 1 here, so that's 1. This is obviously not yellow. So this is the yellow 4, 5 here. So these add up to 33. 45 minus 33 is 12. 12 minus 1 is 11. So these digits add up to 11. So it's either 293847 or 56, but this cannot be 2, 3, or 6. So it could be 4, 5, 7, 8, 9. So this is 4 with 7 adds up to 11. 5 with 6. 7 with 4. 8 with 3. And 9 with 2. Where is the Bluetooth 3 in box 6? Can't be here or here because of Bluetooth 3's in the column. Can't be here because of Bluetooth 3 in the row. And this is eliminated by being a 7, 8, 9 triplet, so this must be Bluetooth 3. That means where is Bluetooth 3 in box 2? Can't be here because of Bluetooth 3 in the row. Can't be here because of the cage. Can't be here because of the cage. Can't be here because of Bluetooth 3 in the row or the column. So this has to be Bluetooth 3. Which means one of these two is Bluetooth 3, which means Bluetooth 3. And this is 7, 8, 9 as a triplet. Bluetooth 3 is one of these two. We don't know which. So Bluetooth 3 is one of those two. Where is Bluetooth 3 in column 6? Cannot be here because of Bluetooth 3 in the boxes. This can't be Bluetooth 3 because Bluetooth 3 in the row. This is 1, so this must be Bluetooth 3, which means the blue has to be 3. It cannot be 2. 2, 8, and 9 only add up to 19. So we can remove these colorings here. And we know these are 3. So this is guaranteed to be 3, which means the yellow 2, 3. So this cannot be 3 here. This yellow has to be 2. Which means the yellow 5, or the yellow 4, 5 has to be 5. This is not 2 and 5, it's a 3, 4 pair. We have 2 and 6 here. This is 1, 3, and 4 then. So this is 4. And this is 3, 8, 9 adding up to 20. So this cannot be 2, 9, cannot be 3, 8. So no 2, 3, no 8 or 9. This can't be 5 anymore because of 5 in the column, so this is a 4, 7 pair. Which forces this to be 2, 5, and 6. 5 cannot be either of these, so this is 5. This can't be 2 because of 2 in the column, so that's 6, which makes that 2. So we know 3 is one of these two. This is 4 or 7. So we can remove coloring here and coloring here. So where are the 2's? 2, 6 as a pair. That's not helpful. Okay. If this were 5 or 6, the problem... Okay, well, it can't be 5 because of 5 in the column. This can't be 6. So that means... Actually, it could be 6. Never mind. So if this is 5, this is guaranteeing that this is 8, 9. If this is 6, that's guaranteeing this is 7, 9. But none of those can be possible because we'd have 4 cells requiring 3 digits only. So this can't be 5 or 6. It's 7, 8, or 9. So we have 5 or 6 there. Same problem here. If this is 5 or this is 6, then this becomes 8, 9, or 7, 9. And this because then column set 6 would have 4 cells requiring only 3 digits. So this can't be 5 or 6. It's 7, 8, or 9. Okay. Remaining digits of box 4 are 5 through 9. Obviously, this can't be 5 or 6. So now we have a 5, 6, 7, 8, 9 quintuplet. And this is only 1 out of 5 or 6. So this has to be 5 or 6 here. So this must be 3 and 4 remaining. This can't be 3 because of 3 in the row. So this is 4, which makes this 3. We kind of already knew that, though. Okay. Well. Remaining, so 4 cannot be here. Where is 4 in box 2 then? If 4 has to be here. Where's 4 in row 2? Cannot be here because 4 in the boxes. This can't be because of Killer Cage. This can't be because 4 in the column, so 4 has to be there. 4 eliminates 4 here, so this is 7, which makes this 4. This 8, 9 pair eliminates 8 and 9 here, so it's 7, which eliminates 7 in the rest of the row and column. Remaining digits in column 5 are 8 and 9. We have an 8, 9 pair in box 8, which eliminates 8 and 9 in the rest of the box, so this cannot be 8 or 9. It's 4. That leaves this as 7, 8, and 9 here. 4 eliminates 4 here, so that's 3 and 4. We know where we have 8 threes. We know where the last 3 has to be. It has to be there. Where is 4? In box 5, cannot be here or here because of 4 is in the column. Can't be here because of 4 in the row, and this is filled out, so 4 has to be there. We have 8 fours. We know where the last 4 has to be. It has to be there. Okay. Where is 6, 7, 8, and 9? Where is 6 in box 5? It has to be one of these 2 digits. So this is guaranteed to be 6 in 6, 7, 8, and 9, which means this is just 7, 8, 9 there. And this has to be 5 through 9, with a guaranteed 6 being one of these 3. Okay. These remaining digits in row 3 are 5 through 9 also. This can't be 7 because of 7 in the column. Remaining digits in... These are 5 through 9 here, and cannot be 6 because of the 2, 6 pair in the box. This can't be 7 because of 7 in the column. Okay, so if this is 5, we have 8, 9 as a pair, as a possibility here. Oh, we have a... Okay. No, that doesn't help. One of these... Well, we don't know. We do know 9 has to be in both of these. So this cannot contain 9 in the rest of rows 1 and 2, which means we have 2, 5, 6, 7, 8 possibly. And 2, 5, 6, 7, 8 here. This can't be 7 because of 7 in the column. Oh, remaining digits in row 8 are 2, 5, and 6. Interesting. This can't be 2, 5, or 6 because of 2, 5, 6 in the column. Huh. Let's start coloring 8s and 9s. So we'll mark this as pink and this as orange. Therefore, this must be pink here. This must be orange here. Pink is one of these two. Orange has to be one of those two. This can't be pink here. This can't be orange here. Hmm. Hmm. Let's see. One of these two is guaranteed to be 9. Oh. Okay. Right. So this can't be 9 because we have a guaranteed 9 here. One of these two is guaranteed to be 9 here. One of these two is guaranteed to be 9 in column 5, which eliminates 9 in the rest of rows 5 and 8. This is a classic X-Wing here. Yeah, and it's been a while since I've done just classic Sudoku rules. So that eliminates 9 in the rest of the rows. 8 and 9. So that means this can't be 9 either. Do we have another X-Wing anywhere? I don't know. Maybe? No, that's just 8 and 9. 9 is one of these 4. 9 is also here, 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 here. What else do we have? We have something here. 9 cannot be here because 9 is guaranteed to be in both of these cages. 9 can't be here because of the X-Wing now. 9 can't be here because of the X-Wing. Where is 9 in column 8? It has to be here. So this is 9. That forces this to be 8. There's no more 8 in column 7, so this can't be 8 here. So if this is 6, 7, 9, the 7, well, that's not true. It could be 6, 7, 9 there. This is guaranteed to be 9, which eliminates 9 from being here. Aha. Because all of these cells see that cell. So this has to be 9 in this cell here, which means the pink cells are 8s. So these are 8. The orange cells are 9. So these are 9. That means this cannot be 9 here. This 8 eliminates 8 here, so that's 7, which makes that 9 there. That eliminates 7 here. in column 1. This cannot be 8. This is 5, 9, and 8, or 6, 9, and 7. So this can't be. This is 5, 6, 9 as a triplet, which eliminates 5, 6, 9 in column 3. And this can't be 9 or 8. It's 7, which makes this 8. 7 eliminates 7 here. This can't be 7 or 9. It's 8, which means this can't be 8 or 8. It has to be 9. So this is 9, which eliminates 9 in the rest of the row. This can't be 9 in the box. Whereas the 9 in this cage, it has to be here. So this is 9 there, which eliminates 9 in the rest of the column. This can't be 9 because of 9 in the box. 8 eliminates 8 in the rest of the box. So we have a 5, 6 pair now in box 4, which eliminates 5 and 6 in the rest of the box. So this is 9. That eliminates 9 here. Okay, so we can remove the colorings here. We should have all the 9s. We have 8 9s, so we know where the last 9 has to be. It has to be there. So this cannot be 9 there. This 8 eliminates 8 here, so it's 7. That eliminates 7 in the rest of the row. Okay. These 8 eliminates 8 in the rest of the box. This is 6, 7 as a pair, which eliminates 7 here, so that's 8. This is 5 and 8, adding up to 22. This cannot be 5 and 8, therefore it's 6 and 7, adding up to 9. That leaves that as a 5. 5 eliminates 5 here, so it's 6 and 5. That means none of these can be 5. This 8 eliminates 8 here. This can't be 5, 7, or 8. It's 2, 6 as a pair. 2, 6 in column 8 eliminates 2, 6 in the rest of the column. So this can't be 2 or 6. It's 5. This can't be 2, 5, or 6. It's 8. Which makes this not 5 or 8. It's 7. No 5 here. No 5 here. 7 eliminates 7 here. So it's 5. This can't be 5 or 6 because of the 2, 6 pair in the column. So it's 7. 8 eliminates 8 here. So this is 2, 6 as a pair, which forces this to be 8 here, which forces this to be 6, which makes that 2, which makes that 6 and 2. 2 eliminates 2 here, so it's 6 and 2, which makes this 6 and 2. 5 eliminates 5 here, so it's 8. That leaves this as 5. And 6 eliminates 6 here, so it's 7 and 6. And that's the solution. Yeah, we used an X-Wing for the first time in a long time. I haven't done X-Wings in a long time. That's when I used to do, like, normal Sudokus a lot. But I don't know, I just enjoy the variants so much more that I prefer doing it. But it was kind of a nice blast from the past of using some normal Sudoku tricks to basically try to solve this puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.